Hello everybody, this is Jim Corkins, and it's very nice to meet you. We are starting out with kinematics, and this is Introduction to Motion. If you haven't started the reading, please start the reading now. Those readings and those chapters will be indicated in Canvas. Okay? So starting out, Introduction to Motion, the first things that we are going to do is we're going to look at how position, distance, and displacement, what are the similarities and what are the differences. We're going to look at average speed and average velocity. Again, what are the differences and what are the similarities, and instantaneous velocity and motion diagrams in this module. Okay, so moving over here, let's start out. So this is an exercise and I want you to think about it, and we're going to concentrate on number 2 here where it says positive velocity but negative position. So it is possible to have a positive velocity but a negative position. So take a moment and think about how is that possible. Okay, and in a second I'm going to ask you to pause the video, but I want you to really think about how that's possible. So how is an object, not multiple objects, just one object, like a ball or a car, how is it possible for it to have a positive velocity but a negative position? Okay, pause the video now. Okay, hopefully you've come back, and this is going to be what we're going to do. This is our introduction, and this is where we begin with vectors. All right. Now, if you hear me thumping around in the background, I'm kind of setting up my pen and my writing pad. So, positive velocity and negative position. So, position and velocity are two completely different things. Yes, you could use one to calculate another one and vice versa. However, they are fundamentally different concepts. Okay? So, if you have a negative position, and I'm just going to say, let's call this a negative position. Let's say right here, you're standing right here at the positive. Actually, we're supposed to do a negative. So let's start here at the negative 2 meter position. You're standing there not doing anything. So you have to establish a number line and you have to establish a 0. Okay. Anything to the right of that 0 is counting in the positive direction and increasingly becoming more positive up until really large numbers. Anything to the left of that is increasingly becoming more and more negative. Okay. Now, really, as far as distance-wise, a positive 1 and a negative 1 are the same distance from 0. But it's a negative 1 is just saying that negative means to the left, positive means to the right. So position, think of position as something on a number line. In our case, this is going to be in the x direction. So that means if you have a negative 2 meter position, you are to the left of the 0 by basically 2 steps. Now, velocity is a vector. Okay? Vectors can point to the right. That would be a positive velocity in the x direction. Vectors can point to the left, which would be a negative velocity in the x direction. Okay? Now, the longer that vector is, the faster it's moving. So the length of the vector tells you how fast the object's moving. What's its speed? The direction that it's pointing is basically the direction of its movement. So for example, if I had a really long vector that was to the right of this, and if this was positive 1v, this would be like positive 2 velocity in the x direction. So it's twice as big. That means it's going twice as fast. Okay? So to the right is a positive velocity, to the left is a negative velocity vector. The size of the vector tells you how fast the object's moving. So if you're standing here at the negative 2 meter position, you could be traveling to the right you could have a velocity vector to the right in the positive x direction. All that means is no matter where you're standing, you are moving to the right. So this vector could, maybe I should have made that a little bit smaller. This vector, and in fact, I'm going to just grab this guy. Let's erase this for a moment. I'm going to say this. I'm going to move this dot over here. So we're going to now be standing at the -4 meter position. So if your velocity vector is to the right, so that'll be a positive velocity vector in the x direction. You could be moving to the right anywhere on this number line. You could be standing at the -4 meter position, moving to the right. You could be moving to the right, standing at the 0 mark. And you could be moving to the right, standing here with positive positions. So that vector, the direction of that vector is independent of its position. That means you could move to the left or to the right at any point, wherever you're standing on this scale or number line. Okay? Now, with these right here, the size of the vector, notice that vector is 1 meter long. So this vector would be positive, it would be the size of positive 1 meter. Again, the longer the vector is, the faster it's moving. Okay? Is it possible to have a positive velocity and a positive position? Yes. We just answered that. You could have a negative velocity and a positive position as well. What that means is if you're standing here at the positive 3 meters position, that line is horrible. That means that vector could be pointed to the left. And that would be a negative velocity in the x direction. You could also be standing here at the 0 mark, and you can also have that negative velocity in the x direction. And you could be standing here at the negative, anywhere in the negative position mark, and be moving to the left. So again, a positive and negative velocity has to do with the direction of the vector. Positive velocity vector is to the right. Negative velocity vector is to the left. And those vectors are independent of your position. Okay? So this is how position and velocity are two different things. Velocity is a vector. Position is just where you're standing on a number line. Okay? Moving over here. Let's talk about distance versus displacement. Oftentimes we will, when we talk about distance traveled, we're talking about like how many steps you took that day or what's the mileage on your car. Okay. And that is the actual distance traveled. So here's a boat traveling along a river, and you can see that this boat travels, and I'm going to use this color, travels all along here and travels down to here, and now it's coming to right there. Yet if you notice, so that's the actual distance traveled, right? So this blue line is the actual distance traveled, okay? But displacement is something conceptually different. Displacement is that part of the velocity vector that gives it its direction. And it's a little bit more complicated. So displacement is delta x. Okay. Let's try this. Here we go. So displacement is delta x. And that is your final position minus your beginning position. Okay. And displacement is a vector. So on this thing right here, you could see that this boat started right here, and I will use red. Its starting position was right here, so this is xi, and its ending position after that whole trip is right here. That is xf. So going from where you started to where you ended, this vector is going to be this long. Okay, and that is your displacement. It's your starting position minus your ending position. However, your overall distance traveled, I don't know, I'll call that d. That is kind of like the sum of all of your positions. 1, 2, 3. So that's the summation of all of your positions. Okay, it's not just displacement without the direction. Okay, it's all of these positions that you actually traveled. It is what would be on your step counter or your odometer. Okay, so displacement is your starting position minus your, that's negative. So it's your end position minus your starting position, and distance traveled is all of your positions added up along your trip. Okay, and distance traveled, just like your odometer, doesn't have a direction. Okay, it's how many miles my car, I think, has like 100,000 miles on it. So that is its distance traveled. Okay, so that's how far my car has traveled. My displacement at the end of every day, well, if I start out at home, I hopefully end up at home. So my displacement every day should be 0, even though I might have put 12 miles on my car that day. Now, just like distance and displacement are linked to average speed and average velocity. Okay. Now, average speed, or your speed, is your total distance traveled over a period of time. Okay. So it doesn't tell you anything about your direction, but it's basically the sum of all your little distances right here. So I'm going to put a little equation right here. It's the sum of all of your distances. That is a terrible summation symbol. Over your time interval. And that time interval, delta t, we often use delta t for time interval. It is your final time minus your initial time. So this would be like 1 second minus 3 seconds. So your delta t, the total period of time here, would only be 2 seconds, right? So distance traveled, that's all the summations of all your little steps you took that day, or your mileage on your car over the period of time that day. Displacement, again, is a vector, which means displacement is what gives your velocity a vector, where displacement is your final position minus your beginning position all over your final time minus your ending time. Okay, and I should probably put that up here too. T final minus T initial. And this is all your little positions added up. Okay, so displacement being your end position minus your beginning position, that displacement is what gives your velocity a vector quantity to it. Okay, so it has direction, it has size. Okay, the larger the displacement vector, the bigger the difference between your starting and your ending position. That would increase your velocity. Okay, and it is possible for speed and displacement to be the same thing. Well, the same number, but they are fundamentally different concepts. because speed is based off of distance traveled and velocity is based off of displacement. Okay, so let's try to apply what we just learned. Moving over here. So this is how we're on this slide. We are learning about how position, distance, and displacement are related to speed and velocity. Okay, so in this problem, your house is at the 0 point, right? So in life, your home is 0 meters. It's 0 meters in the x direction, 0 meters in the y direction, and 0 meters in z direction. Okay. Now, what they're saying is that this grocery store is 4 miles. So I'm going to call each one of these as miles. That's what the M is going to stand for in this. Normally that's meters, but we're going to call these miles. So they're saying the grocery store is right here. Here's the grocery store. And I will call this big G. And they're saying the grocery store is 4 miles to the right of your house. Your friend's house is 2 miles left of that. And again, your home is right here. And I'm realizing I should probably write the G above this, or actually, let's write it below it. The G is down here. Here's your home. And here is your friend's house. Okay. Now, the problem says this: if you walk from your house to the grocery store and back within 2 hours, what is your distance traveled in miles and your speed in miles per hour? So distance traveled is related to speed. It's also asking for what is your displacement and velocity in miles per hour. Okay, so from here, here is when we're also beginning what is called a motion diagram. So you walk from here to here. So this is 0 hours, and this is 2 hours. Okay, and I probably should make these smaller because I'm probably going to have to. Okay, so you're going to walk from here to here, and this is, you start out at the 0 hour mark, and zoom in, 0 hours, and in 2 hours, you're at the grocery store. So you walk to the grocery store, and I'm going to just say this, it's going to take you 1 hour to get to the grocery store. Because if you're like me, you like to take a long time to walk. 1 mile an hour. That's very long. Anyways, so that means you walked to the right. Your final position is 2 hours. Your is 4 miles to the right. So you walked, your final position is 4 miles to the right. Is at the positive 4 mile mark. You started out at the 0 mile mark over a period of 2 hours, over the period of 1 hour. So that means you had a velocity of positive 4 miles per hour per 1 hour. Really got to zoom in a little bit more. So this is going to be positive 4 miles per 1 hour. And then they said you went on a return trip. So here, you're now here at the 2 hour mark. And you end up back at your home. Actually, that should be, sorry, that's confusing. This should be 1 hour. So it took you 1 hour to walk to the store. And now you've shopped in 2 minutes because apparently you're just getting gum or something. And now you're walking to the left. And that means your starting position is the positive 4 miles positive 4 miles. I suppose 4 miles in 1 hour is pretty quick. I don't know. I try not to exercise unless I'm being chased by something. Okay, so here we go. Your initial position is positive 4 miles. Your final position is 0 miles. And remember, delta x is final minus initial. And this part of the trip is going to take you 1 hour as well. So this is a negative times a positive. So this part of the trip is negative 4 miles over the period of 1 hour. So in other words, you started here and you ended here. So your total displacement for that day is 0 miles. And so you started out at the 0 mile mark and you ended up at home. And you did that over a period of time of 2 hours. So your displacement, which is going to be weird, and I don't know why I put the hours there. So your displacement, which is going to be weird, is going to be 0 miles. Which kind of makes it look like you didn't do anything that day. But your trip that you took, which is the sum of all your distances, well, you walked 4 miles to the right and 4 miles to the left. So if you sum up all of that, you walked a total distance of 8, and it shouldn't be plus because it doesn't have a direction, of 8 miles. And remember, speed, which is a little hat, is the sum of all your distances over the period of time. So your speed that you walked, and including shopping, is 8 miles over the period of 2 hours. While your velocity, which is your displacement over time, is going to be 0 miles. You started and ended at the same place over the period of 2 hours. Even though your velocity to the right was a positive 4 miles an hour and your velocity to the left is a negative 4 miles for every 1 hour, your overall velocity, your average velocity for that whole day is going to be 0 miles for over a period of 2 hours, while your speed is going to be a total distance of 8 miles over that 2 hours. So I'm going to fill this in over here. So your distance traveled is going to be 8 miles, and is going to be 8 miles over the period of 2 hours. While your displacement for that whole day is 0. So this is 0 miles over the period of 2 hours. And I'm writing that for a specific purpose because it kind of tells a story. If you reduce this, just a little cautionary thing, and I'll talk down here. If you take this guy and reduce it, so you divide both things by 2, you will get 4 miles over the period of 1 hour. Now, when I look at this tells me, this looks like this to me, that you only walked 4 miles over the period of 1 hour. Okay, and yes, you could say, well, you did actually do 2 hours, but it's a little confusing. And the way you talk about speed and velocity is the way your brain starts to think about these things. So just for right now, we're not going to call it velocity as miles per hour or meters per second. We're going to call speed and velocity 8 miles, the total distance over the period of time, or the total displacement over the period of time. So speed is a total of 8 miles distance over the period of 2 hours. Velocity is 0 miles displacement over the period of 2 hours. If you keep talking about it that way, talking about those two things, what you're doing is you're getting your brain to start thinking a little bit differently. Okay? Moving right along, we're going to take what we just learned here, and I want you to try this one on your own. So here's the situation, same thing. The grocery store is over here to the right, and it's at the positive 4 mile mark. You live at the 0 mile mark, and your friend's house is at the negative 2 mile mark. Now, and those are positions. In this problem, it says you're going to walk from your house to the well, actually, you're more like going to run from your house to the grocery store, pick up your friend's groceries that are waiting for him, and then so you're going to walk to the grocery store in 1 hour, and then from the grocery store to your friend's house over the period of 3 hours. Okay, and so the question is asking, what is your distance traveled? What is your speed? What is displacement? And what is your velocity? So I want you to go ahead and try this out. You're going to walk from your house to the grocery store in 1 hour, and then from the grocery store to your friend's house in 3 hours. So what is the total distance traveled, and what is the total speed, average speed, and what is the displacement of that trip, and how is that related to velocity, and what is that velocity? So try it out, take a moment, and pause the video now. Okay, hopefully you're back. All right, so let's do this. Here we go. You start here, and at the 0 hour mark, you zoom in, and you get to the grocery store, and it said 1 hour. So you're at the grocery store, so that means you hoofed it, and a quick way to count displacement is just 1, 2, 3, 4. So you walked a total of 4 miles to the right over the period of 1 hour, or you had a displacement of positive 4 miles over the period of 1 hour. Now, starting here at the 1 hour mark, you're going to walk all the way to your friend's house. So this huge distance, and they said it's going to take you a total of 3 hours to get there. So that means you're going to arrive at your friend's house at the 4 hour mark, because 3 hours after 1 hour is 4 hours. So this displacement, and by the way, I'm writing velocities here. This is the velocity. This displacement here in the red is going to be 1, 2, 3, 4, 5, 6. So that'll be -6. Oops, should be using red. -6 miles displacement over the period of 3 hours. And if you don't believe me that works out just by counting it, if you take your initial position, which is positive 4 miles, and we're going to put it in brackets, we're going to subtract that initial position from your final position. Your final position is the -2 miles. And we're going to do this over the total period of time of 3 hours. So this guy's velocity, which is his displacement, -2 miles minus a +4, which is going to be -6 miles displacement over the period of 3 hours. Okay. So what is that saying? Well, if you started here at the beginning of your day, you ended here at the end of your day at the 4-hour mark, well, your total displacement for that day is going to be 2. It's going to be -2 miles over the period of, what is that, 4 hours. So that's -2 miles displacement over the period of 4 miles. So your displacement is -2 miles, and your total velocity is going to be -2 miles over the period of 4 hours. Okay? Now, your distance traveled. Your distance traveled is, well, you got to now count steps. So that's going to be 1, 2, 3, 4 miles. And then you walked 5, 6, 7, 8, 9, 10. So your distance traveled is 10 miles. And you walked that 10 miles over the period of 4 hours. Okay? And that is how distance and velocity, how distance and displacement are different from each other, and how they relate to speed and velocity. Okay? All right. Now, we are kind of talking about, we did kind of do a little bit of motion diagrams and that kind of stuff. Now, what we're going to do is talk about specifically what is a motion diagram and how do you draw continuous motion when an object is moving at a constant velocity. So we're going to go through all of these steps. First of all, we're going to establish a coordinate system, okay? And then we're going to sketch the symbol using little dots to represent its motion at certain time intervals. In between each dot, I typically use 1 second because we're going to be working with meters per second. And the number line is going to represent the distances, just like we saw. So what we're going to do is we're going to take a look at these pictorial representations right here, and I'm going to train you on how to create a motion diagram. They are one of the most powerful tools that we could use besides equations that can help us visually see and immediately calculate velocity, displacement, distance, and speed. Okay? So here's the situation. You took an initial picture right here. So at the 0 second mark, because when you count in physics, you start counting at the 0 second. That is your initial picture. That is your initial position starts at 0 seconds. Okay? So when you count in physics, you start with 0. 1 second later, you took this picture. 2 seconds later, you took this next picture. And then 3 seconds later, you took this third picture. Okay? Now, we need to establish a 0 line. Now, you could put the 0 right back here. But I like to pick something that is static, right? That's not really changing. And across all 4 of these pictures, across the total of 3 seconds, 1, 2, 3 seconds, we have a palm tree. Okay, so I'm going to call this palm tree the 0 meter mark. To the right of this would be +1 meter. To the right of that would be positive 2 meters, and so forth. To the left of it is going to be negative 1 meter, negative 2 meters, negative 3 meters. Okay? Now, and we're measuring to the front tire. So right here, our first picture was right here, was really far away, was the 0 seconds. This is 1 second, this is 2 seconds, and this is 3 seconds. So this set of pictures is each one of these pictures laid on top of each other. And if you do that, what you get is, well, it's a movie, is what it is. So, and it shows the positions of the object, of the car, at different points in time. So the car started out here at the negative 3 meter mark at 0 seconds. 1 second later, it was right here. Let's draw that velocity vector. Well, you started here, you ended here. You're moving with time. And how far did you go? You went 1 meter, 1 meter to the right. So the direction of that vector is to the right, and it took you 1 second to do that. Okay? So the velocity of the car right now from 0 seconds to 1 second is positive 1 meter in that 1 second. I always put my velocity right there. And I do not recommend saying 1 meter over 1 second. Put the plus in front of that. That specifically tells you that you're moving to the right. If you don't have a direction to this, that is implying speed. You may say, oh, well, that's actually a positive. What I do is I try to make sure I eliminate the possibilities of mistakes, because I make a lot of mistakes. So by me drawing that plus in front of that, on top, in front of that one, it's showing it's a positive 1 meter displacement over the period of 1 second. It moved to the right 1 meter over that 1 second. Okay. Now, at the 2 second mark, it moved to the right another meter. It moved to the right another positive 1 meter. So it had that displacement of positive 1 meter again over the period of 1 second. Finally, it ended here at the 3 second mark. So it moved to the right this last positive 1 meter displacement over the period of 1 second. Okay, so these are those instantaneous velocity vectors. These are called instantaneous velocity vectors. At the 1 second mark, this is the instantaneous velocity vector. At the 2 second mark, here is the instantaneous velocity vector. At the 3 second mark, here's the instantaneous velocity vector. I don't know what was happening prior to the 1 second. I would assume there was also a positive 1 meter per over that period of 1 second at the 0 second mark. But what we know for sure is that it moved to the right positive 1 meter over 1 second again and again. So it had a constant velocity. These represent the instantaneous velocities. Oh boy. That is horrible writing. So these velocities. So all of these are its instantaneous velocities. Okay. Now, its overall average velocity, well, it started here at the 0 second mark. It ended here at the 3-second mark. So it's over the period of 3 seconds, it went to the right positive 3 meters over that period of 3 seconds. So it had a positive 3 meter displacement over the period of 3 seconds. So this guy is the average velocity. And yes, you could also say that it took 1, 2, 3. So its distance traveled was 3 meters over the period of 3 seconds. But we're here to learn about velocity and instantaneous velocity. Okay. Okay, and it had a continuous instantaneous velocity. Okay. Now, we are going to practice this, and I think this is our last exercise, okay, about how position, distance, and displacement are related to each other, again, and how they're related to a motion diagram. So here you're running around a track. You started out at the positive 1 meter mark. So you started at A. You 1 second later, you were at the positive 3 meter mark. At the 2 second mark, you were at the 4 meter mark. And then at the 3 second mark, you're again at the positive 2 meter mark. At the 4 second mark, you were at the negative 1 meter mark. And the 5 second time, you were at the negative 3 meters position. At 6 seconds, you're at the negative 4 meters, and that's C. And then finally, 1 second later, which is at the 7 second mark, you arrive back in time. So in this, just so you know, in this track, we're just going to say you're moving left and right. Don't worry about the up and down part. So you, from A to B, you just went to the right. And then from B to C, you just went to the left. And then from C to A, you went back to the right. Okay? So what I want you to do is I want you to try filling this out. And let's do A to B together. Okay? So distance is a hat. I was putting a D in here, but since we are using the X direction, we're going to call this X hat, and that's the sum of all of your positions. Okay? Now, from A to B, you went 1, 2. So you went a total of positive, that doesn't have a direction. Whoops. So you went a total of 2 meters. Now your displacement, actually, hold it. You went a positive. So, oh, no, I'm totally wrong here. You started out at the 1 meter mark and you went 1, 2, 3 meters. There we go, Jim. So this is a total distance of 3 meters. Okay. Now your displacement, which is right here, this is going to be positive 1 meter. Well, actually, positive 4 meters minus a positive 1 meter. So that's going to be a total of 1, 2, 3 meters to the right. And that is your displacement. In other words, positive 4 meters minus a positive 1 meter, that is positive 3 meters. Okay, so that's how I got that. Or you could just count 1, 2, 3, just like I did. Okay, now the period of time that took was, well, you started at 0, 1 second, and 2 seconds. So your average speed is going to be 3. You gotta zoom in, so the ink on this is very thick. So 3 meters over the period of 2 seconds. And maybe I'll write this one a little bit to the left. 3 meters over the period of 2 seconds. Now, velocity, which is displacement divided by time, is going to be a positive 3 meters over the period of 2 seconds. So they look the same, they are fundamentally different. Okay, this is the number of steps, which happens to be your end position minus your beginning position. Coincidence. Sort of. Anyways, now let's do B to C. I want you to go ahead and try this again on your own and try doing the B to C vector. Try to do a distance, displacement, speed, and velocity just like we did together. So try this on your own. Pause the video now, please. Okay. If you've tried this on your own, hopefully I'm just going to be telling you what you should have got. So starting out at the positive 4 meter mark, you would have walked at B, you would have walked 1, 2, 3, 4, 5, 6, 7, 8 steps. So you would have taken a period of you would have walked a total of 8 meters. That's what your step counter would say. Now, your displacement, well, that's positive 4 meters is your starting position, which you're going to have to subtract from your end position, which is negative 4 meters. So that displacement is going to be a negative 8 meters. Okay, or in other words, you could say this. You went 1, 2, 3, 4, 5, 6, 7, 8 meters to the left. Now, for the speed is distance traveled over time, which is a total of 8 meters over the period of, well, you started at 2 seconds and you ended at 6. So 2 seconds, so that's 1, 2, 3, 4 seconds. So your speed is going to be an 8 meter distance over the period of 4 seconds. But your displacement is going to be a negative 8 meter displacement. Your velocity is going to be a negative 8 meter displacement over the period of 4 seconds. Yes, I know that reduces down to negative 2 meters per second. But again, we want to talk about this properly. Negative 2 meters per second is not the same thing, in my opinion, as negative 8 meters per 4 over the period of negative 8 meter displacement over the period of 4 seconds. The way I talked about negative 8 meters displacement over the period of 4 seconds tells you a more whole story of what is going on with that vector. You don't have to reduce. Why don't you try C to A by yourself? So go ahead and try C to A and pause the video now. Okay, so starting out at C, you're at the negative 4 meter mark, and then you went 1, 2, 3, 4, 5 steps to the right. So this is going to be a 5 meter displacement. And just like the other ones, let me erase this. We could calculate it using equations, which is good to do, but I like to do calculations after I've tried it out in my head. That way I know if the answer is weird in my calculations, I might have made a math error. So here, I started here, I would have walked 1, 2, 3, 4, 5. So this is my end position, which is positive 5 meters away from this initial position. So the initial position is negative 4 meters. We're going to subtract that from a positive 1 meter. Positive 1 minus negative 4 is going to be a positive 5. And it's also a double negative. That's irregardless. Sorry about that joke. Okay, moving right along. So this only took over the period of from 6 to 7 seconds. So that's 1 second. So your speed is going to be 5 meters over that period, 5 meter distance over that period of 1 second. And your velocity is going to be a positive 5 meter displacement over the period of that 1 second. Now, going the total distance from A to A. Well, now you're doing changing directions, and when you change your direction, that's when these numbers don't really work out to be the same. You won't have the same distance as you will displacement. Okay, so if you walked, here's what I mean. If you walked this whole track, that means you would have walked starting from the 1 meter mark, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you would have taken a total of 16 steps. That is what all of this stuff is added up to. So the total trip is 3 meters to the right plus 8 meters to the left plus 5 meters to the right, 16 meters. And I don't know why I put a plus. I'm crazy about putting directions on stuff. Now, displacement is a different thing, okay? You started here, your starting position is 0 meters, your ending position is 0 meters. So your total displacement is 0 meters, okay? Or in other words, if you add up all of your displacement vectors, positive 3 minus 8 plus 5, you get your total trip and your total displacement. Okay? Average speed is going to work out to be 16 meters over that total thing. You started out at 0 seconds. You ended your track run at 7 seconds. So 16 meters. So your total average speed for the whole trip is 16 meters distance over the period of 7 seconds. While your displacement is a 0 meter displacement over the period of 7 seconds. That is your velocity. All right. Now, A to C and B to A, you have to think, okay? You have to take into account the times and everything. So if you went from A to C, you started here at the 1 meter mark, went to the right, went to the left, and ended right here. So I want you to try the A to C and also B to A parts, okay? So try those out. And pause the video now. Okay, we're back. So you started here, and so the distance traveled from A to C would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be 11 meters. Now, your displacement, and I'm going to erase these guys because they might confuse me later. Your displacement is you started here at the positive 1 meter mark. That's your initial position. And you ended at the negative 4 meter mark. But let's count first. So you started here. 1, 2, 3. Oh, well, actually, hold it. We can't count. So we could add and subtract, but I would rather just, if you started here and you ended here, your starting position is here. You started here and you went, and this is for displacement. You ultimately ended here. Then that means you would have gone 1, 2, 3, 4, 5 meters to the left. So that should be negative 5 meters. Okay. Negative 4 meters minus a positive 1 meter is negative 5 meters. Interesting. So, and this would have taken you 6 seconds to do this. So your speed would be 11 meter distance over the period of 6 seconds. Your velocity would be negative 5 meters displacement over that period of 6 seconds. All right, let's try from B to A. Now, if you started out at B, and remember you have to go around the whole track, that means you would have passed A on the other side of the track. So starting out at B, you would have gone 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13. So positive 13. Why am I putting positives in front of those? I'm driving myself crazy. Okay, so you started out at B, and you would have to go right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 9, 10, 11, 12, 13, right? But if you started out at here, this is your starting position for displacement. Your ending position is right here. That means you would have only, your end minus beginning is going to be 1, 2, 3. It'll be 3 meters to the left. In other words, starting out at the positive 4 meter mark, your end position is the positive 1 meter mark. So positive 1 minus 4 is going to be negative 3. And at the 2 second mark, your time would be 2 seconds. So that's going to be 1, 2, 3, 4, 5 seconds. So this is going to be 13 meters over the period of 5 seconds. And your velocity is going to be negative 3 meters to the left displacement over the period of 5 seconds. So your speed would be a 3 meter distance over 5 seconds and a negative 3 meter displacement over the period of 5 seconds for your velocity. Okay? And that ends our very first lecture on the differences between, so that's ending this first introductory lecture. I'm going to go all the way back over here about position, distance, displacement, average speed, average velocity, instantaneous velocity, and motion diagrams. I hope you enjoyed it. Thank you.